All right, here's my second attempt today at this. I had to go at the first one, but not happy with it. I'm gonna do it all of them again. Okay, so a car and a jet plane race one another down the runway. The car increases at a speed v1 at a constant rate, while the speed of the jet is given by that. After 5 seconds, the car and the jet have the same speed of 50 meters per second, as shown. By considering the different quotient, find the average acceleration of the jet during the 5 seconds. The fact that says average acceleration, you need to use the average rate of change. Now, for this, we need to find 2 points on the curve. Here, it's already given you one. And what we're going to say is this time we've got t as our x and v as our y. So average rate of change is just the gradient. So if I was to pick 2 points in this line, what's the gradient of that line? And same as gradient, we're going to say, we'll say average rate of change. We don't say m. We'll say average rate of change. We'll just say average is equal to, I'm going to put, just like with gradient, it's y2 minus y1 over x2 minus x1. So I've got 50 over 5. Now, that's where those two come from. To get the other one, I needed another point on the jet. And because it's talking about the average rate of the jet, I need another one. So what I'm going to do, I'm going to say minus, and I'm going to say 2 lots of 4 squared. Now, the reason I pick 4 is because it is a different spot on the jet axis. And I'm going to say minus 4. Because what I want to do is, hey, if that's 4 there, what is this point? I've got to figure out what value is over there. How do I do that? I substitute it back into the formula. And if we do that, we should get an answer of, where was it? 18. 18 meters per second. Okay, find equation for V1 in terms of the car T. Again, so it's talking about the car line this time. This one. This is just a, can you find the equation of that line? So for me, you know the gradient. So I'm going to do the old way. It goes 50 up and 5 across. It's a rise over run. And it asks if finds a t. So this time I'm going to say V1. Oh, sorry, V, I should say, not V1. V is equal to 50 over 5, which is 10t. And what's the y-intercept? The y-intercept is 0. So that's not a bad one. For what times is the acceleration? For what time is the acceleration of the car greater than the jet? So we have to say, okay, what have we got here in terms of the things given? We're given velocity. So velocity, and we got to turn that into acceleration. How do we do that? By differentiating. And we want the car is greater than the jet. So the velocity of the car was 10t. And we want that greater than the velocity of the, well, we're talking acceleration, but to start off with 2t squared. So we want that to be greater than that. We'll differentiate both sides just so we got it. So we want 10 is greater than 4t. And then we've got 10 over 4 is greater than t. And then we can say t is, t is less than 5 over 2. Same thing. Okay, so that's the time when the acceleration of the car is greater than the jet. who is winning the race after 5 seconds by how many meters. The fact they're talking about meters here, we've given things in velocity. We've got to turn things back into displacement. So how do you go from velocity to displacement? We're going to integrate. So we want to integrate both the car and the jet. Okay, so we've got to take our, we'll integrate from 0 to 5 of 10t dt, and the other one integrate 0 to 5 2t squared. From that, we should figure out that do our little do our thing. So we can say that is equal to 10t squared on 2 between 5 and 0, and that is equal to 2t cubed on 3 between 5 and 0. If you do the car, substitute it in, I believe you get 125 meters. If you do the jet, sub in for the sub the 5, I'm not going to worry about 0. I believe you get 83.3 meters. And what it's asking there is what's the difference between the two. Subtract, so car winning distance is equal to 125 minus 83.3, and the car should win by 41.66 meters. All right, got 7 minutes. Let's keep going. So again, tough, but not too bad. Okay, life of a particular LED bulb is normally distributed with a mean of 5,000, standard deviation of 425. Find the Z-score. So we got use the Z-score formula from the formula sheet. X minus U over S. So our score is 5374 minus 5,000 over 5. And I believe from memory that's 0.88, I think. Yep. So that gives us a Z-score of 0.88. By considering Z-scores and consulting the normal distribution table, find the probability that LED chosen at random has a lifetime between 4898 and that. We don't have a Z-score, so considering the normal, the Z-score, and consulting the distribution table. So we've got to do two things here. First, we'll do the Z-score of the new one we got. So 4898 minus 5,000 over, was it 5? That gives us a Z of, I believe it's negative 0.24. Now this bit, now we've got to use the table. So we've got to find 0.88 on there, which is somewhere like about that one, I believe. Okay, negative 0.24 is not on there. However, 2.4 is on there. Okay. What we're going to say for this one is that 2.4 is, if I draw my bell curve, that's my mean. 0.24 would be finding all this part in here, right? We don't want that. We want this part, but reflected on this side. Okay, and the fact that it's symmetrical, what that means is that we can do some trickery here and say 1 minus the value of that. Now we're going to take the value from the table, And we're going to talk about z-scores. So P, the probability of a z of negative 0.24. So probability of a z-score of less than or equal to negative 0.24 is going to equal 1 minus the z-score we had for that, which is 0.59483. Okay, and that should give us a value of 0.40517. Okay, now we want to find between these two. So we're just going to minus our two values from the table. So we'll say the P of the probability of a score between negative 0.24, then x less than equal to 0.88 is going to equal those two subtracted from each other. So 0.81057 minus 0.4517. If you do that, you should get 0.4054. Oops, 0.4054. And that is what we're after. Nice. I don't think I have time for this one. Show 3 minutes. Yeah, why not? Okay, this time, very similar to what we've done. We're going to integrate this one. Continuous random variable. So this looks very, very similar to what we've been doing. We know this is equal to 1. We're going to say the integral, it's just a slight difference on what we've been doing. We're going to say between 5 and 0. A plus bx is equal to 1. Don't forget there should be dx in there. If we integrate that, we should get a to the x plus b x squared over, oops, not over 2. Means it's supposed to be a better version. All right, over 2, and we're going to do that between 5 and 0. And don't forget this equals 1. I'm going to ignore the 0 part, that just goes away, and I substitute in for the x, which gives me 5a plus 25b over 2 is equal to 1. I want to get rid of that 2, so multiply everything by 2, which gives me 10a plus 25b is equal to 2 as required. I'll pause there because I know what's going to happen in the next one.